All right, we're going to write an algorithm that returns the kth node from the end in a linked list. So say I have 1, 2, 3, 4, and 5 nodes in my linked list. And let's say k equals 2. Then I'm going to want to return this node here, the second from the end. All right, so to do this, we're going to have 2 pointers. And we start at the head. And say we have 1 pointer that's just like a temp. And then we have a second pointer that is going to represent the kth node. And so we're going to actually start the second pointer equal to null. And what we'll do is say k equals 3, then we're going to keep our k node pointer 3 steps behind our temp, so that when we get to the end, that will already be in the right position. So we would move t and maybe have like a counter. And every time we move t, we can increase our counter. And then when counter equals k, then we know it's time to put in our k pointer. So if we move here and then t is now here and count is now 2, and then we go here and t is here and count is now 3, and then we also look and see, okay, those are equal, so we know we want to stop for a second, and we know that we want to start, we want to add on our k pointer now. So then every time we move after that, we don't need counts anymore. We can just go until we're until t's next is null. So then we could go and then t would be here, k would be here, t moves here, k moves here, and now our next is null. So we would stop and we would return, we would actually return our k node that we're pointing at, which, as you can see, is 1, 2, 3 from the end. All right, so let's go ahead and write some code. Okay, we're going to return a node. And it's going to take in a head. Okay, let's do a quick check here. If head equals null, we'll just return the head again. Say that we really can't perform this. We could also throw an exception if we wanted. And then that's all the checks we can do right now because we don't know the length of the actual linked list or how many nodes are in it. So what we can do is we know we need to have our temp node for counting, and that will start at the head, and we know we need a counter. Start that at 1. So we'll do a small loop here. So while, oh, and that's what we forgot here, we need to get in k. All right, so I guess we could do a quick check if k, I could put that here, if k is less than or equal to 0 or something, then we can return the head and say we just kind of can't do anything with that, right? So while temp.next does not equal null and while count is less than k, then we want to keep going. So this is just to get our initial before we add on our second pointer. So temp equals temp.next count plus plus. Okay, then what we can do is some quick checks. So if count is less than k, then we know we have a problem because we can't really return the kth from the end. So we could throw an exception or return the head or something. List is less than k or something like that. If count equals k, then we are going to return temp, because that means that it would mean that, say, or no, it wouldn't mean we want to return temp. We would want to return the head, because that would be the number back from where we were. And then otherwise we can go in and we can say we have our second pointer that we need to do, so k temp, and that's going to be equal to the head. And then we can say while temp.next does not equal null, temp equals temp.next, and ktemp equals ktemp.next. Assuming we set this up right, we can walk through it. We can return ktemp. Okay, and we'll walk through this and make sure that we didn't miss any exceptions. So say we have 1, 2, 3, 4, 5, 6, 7. Okay, that's null. Here is our head. Okay, and so we can, let's just go ahead and say k equals 4. Okay. So we're given our head and we're given k, which is 4. We're going to do a quick check. If head is null, head's not null. If k is less than or equal to 0, which it's not. So we have our node temp equals head. So here is temp. And we'll keep track of count. Starts at 1. So while temp.next does not equal null and count is less than k, so we've got that condition is met. So temp equals temp.next. So temp is now here, count plus plus. Go back around. While temp.next does not equal null, which is true, and count is less than k, which is true, then we increase our temp and count plus plus. Then while temp.next does not equal null, which is true, and count is less than 4, which is true, temp equals temp.next, count plus plus. So now this condition is going to fail because count is not less than 4. So we go down into here. If count is less than k, which it's not. If count equals k, which actually we don't want, that's not going to work because it will always be equal at that point because that's where we want to put that in. So this condition needs to have some work done to it. But let's go ahead and pretend that that is not there. And node ktemp equals head. So ktemp goes here. And then while temp.next does not equal null, so that's true. So temp.next does not equal null. Then we do temp equals temp.next. So here is temp, and ktemp equals ktemp.next. Okay. And then we keep going, and temp.next does not equal null, so we move up temp. And we move up ktemp. And then we're still not at null, so temp increases. And ktemp increases. And now temp.next is equal to null, so we stop. And we're going to end up returning ktemp, which is here. And that is 1, 2, 3, 4th node from the end, just as we were hoping for. So the one condition we need to fix is if count equals k, but I think what we actually want is if temp.next equals null. Because that way it would say that our temp, let's say our temp is here, but let's say that this part didn't exist and this was null. Then we would have gone through our cycle, and instead of even dealing with ktemp, we would have known that temp is at the end, and that means we would have needed to return head because it was exactly the amount of elements. So that will take care of that. And we have our checks in for when we hit the end of the list. And so the complexity of this is simply O of n, because we go through the entire list one time. And it takes up no extra space.